In the previous examples and video, what we did is we found the reference angles. In this video, we're going to find the reference angles and use those reference angles to find the exact values of some common angles. They have some summaries of things that I went over in an earlier video about the signs in the quadrants, first, second, third, and fourth. And they also have some values here for sine, cosine, and tangent of some 30, 60, and 90, or 30, 60, and 45 degree angles if you want to reference those. I would recommend that you, if you don't have them memorized through using them, that you just memorize your 1, 1, square root of 2, and your 1, 2, square root of 3 ratios that we've been working on. Okay, so find the exact value of each function. So the tangent of 5/3, what I'm always going to do with these, because I'm a little bit leery of radian measures yet, I'm going to take the 5 pi thirds, and I'm going to rewrite that as 5 pi thirds. And pi thirds is equivalent to 60. So that's 5/60. So that means we're going to find the tangent of 300. So in order to draw this reference angle, I'm going to first draw the angle starting with the positive x-axis. We're going to rotate 300 degrees around counterclockwise because it's positive. And then if I stop at 300 degrees, that's this angle, which really in terms of radians was 5 pi thirds. That leaves us with, and if I want to keep working with degrees, then I would say we have to be 60 degrees short, because the reference angle always goes back to the x-axis. We're 60 degrees short of creating a full rotation. So the reference angle is 60 degrees, or in terms of pi, it's pi thirds. So our reference angle is pi thirds. If it's a 60, then what we know is, if we have our triangle memorized, across from the 60 is always a square root of 3, then across from the 30 is always a 1, and the hypotenuse is always 2. Now the hypotenuse will always be positive. If we work to the right, the x is positive. When we work downward in the fourth quadrant, the y's are negative. So hopefully I can emphasize that that's negative. So we're asked to find the tangent on this problem. And the tangent is always described, and I'm going to go back and put it back to the original. The 5 pi thirds is equal to the y over x, which means the y value is the side opposite, which is a negative square root of 3, all over the x value, which is 1. So it's nothing more than a negative square root of 3. We have to find exact values for each of these trig ratios. Okay, so for 4b, again, I'm thinking when I'm drawing this, eventually you don't have to, I'm just showing you kind of a crutch in which you can get by on. It's 5 of these pi 6, and a pi 6 is 30 degrees, and if it's not equals, the sine of 5 times 30 is the sine of 150 degree angle. So what we're going to do is we're going to go on the positive x-axis, and then we're going to rotate 150 degrees counterclockwise. So this is 150 degrees. Then our reference triangle, remember, get your terminal side in here, and then you always go from the terminal side to the x-axis, which means that's going to finish that off with a 30 degree angle, which is pi 6 for your reference angle. So to find this, the sine of 5 pi 6 equals, now the sine means we need to know the opposite side length. Opposite of 30 is always a 1. Opposite of 60 is always the square root of 3. And the opposite hypotenuse is always 2. So since we're doing sine, this is a positive because we went upward. If we were doing cosine, we need to know that that was negative. But because we're only doing sine, I just need the y value and the hypotenuse, so it's just a 1/2, and it's positive. Okay, and now the final one is the secant of negative 135. So we start on the positive x-axis, we rotate a negative 135 degrees. That should put us right in the middle of quadrant 3. This is 135 degrees going negative when clockwise from the positive x-axis. Now we want to draw our reference angle. The reference angle always goes from the terminal side to the x-axis. So this is going to create our reference triangle. So now we need to figure out how big that reference angle is. How many degrees short of a half a turn is that? Well, a half a turn is 180. We want 135, so that means our reference angle sitting in here is a 45. So on a 45, 45, 90, our ratios that we have memorized are 1, 1, square root of 2. Now the hypotenuse is always positive, or the radius. Since we went downward, this is negative, and since we went left, it's negative. And anytime we're in the third quadrant, our x and y values are both negative. So when we do the secant, of a negative 135, I know I'm searching for the r value all over the x value. Well, that means we have an r value of square root of 2 over the x value of a negative 1, so it is a negative square root of 2. Okay, so that's how I would attack those types of problems with reference triangles.